All right, so that's a lead in into the big idea. And the big idea is the being able to do the solve quadratics by factoring. I call this is the one you're going to use the most, and I call this I call this X factoring. Or I call this figure it out method. Figure it out. Or I call this, I used to call it loops. I think Miss Musial calls it loops. I think we both used to call it loops. Maybe she still does. I don't know. Okay, so how does this one work? So now I'm going to try to teach it to you by working backwards using distribution. So if I said to you, start to distribute this thing. So you would distribute 3x times 2x. So I'm going to underline this with colors. You would take the 3x and you would multiply it by the 2x, and you would get 6x squared. Then you would distribute. I'm going to do the loops underneath instead of normally we distribute on the top, but I'm going to do it underneath so that there's some room. So we did 3x times 2x. That gave us this. Then you would do 3x times negative 5, get negative 15x. Then you would take, so you've done the 3x to both of them. Now you're going to do the 2 to both of these. 2 times 2x is 4x. And then lastly, you would distribute the 2 times the negative 5, and you would get negative 10. So now when I combine like terms, I get 6x squared minus, I think this was the color I used, minus 11x minus 10. So look at where these pieces come from. This is what the big takeaway is supposed to be. This is the big idea here. These first two terms multiply together to make this coefficient out front. So that the first two terms come together to make the coefficient of the x squared term. The last two terms, the 2 doesn't have a variable, the negative 5 doesn't have a variable. We call those constants. The constants multiply together to make the constant. 2 times negative 5 makes negative 10. Now, what makes this tricky is that you have to come up with these numbers, and then these numbers in combination actually come together to make the middle term. So these two, 3x times negative 5 added to 2 times 2x is what comes together to make that middle term. All right, so hopefully you've seen this before. If you've been at this school, you definitely have. You've seen it at least twice in Algebra 1 and Algebra 2, but I can't believe you'd get through geometry without doing some of it too. So let's get into it. So now we've got our problem. So what we have to do is we have to figure out what goes here, what goes here, what goes here, what goes here, and then we're going to figure those out. We're going to use this as a hint to figure out what these numbers are. So I'm giving you this, and you're trying to get to this spot here. So I do a couple of things first. I recognize, like I said, I call this x factoring. So I start off by making my x. Then I start off, I call it the template. Here's the template. I'm going to have two things multiplied together. I know that my answer is going to look like this. So I put my two parentheses in there. I also know that this is going to have an x and this is going to have an x. Then I'm starting to apply the ideas of how distribution works to get to this spot. So I know I'm going to use the same colors that I used before. Position, I call this position 1, and I call this position 3. 1, 2, 3, 4. Position 1 and position 3 have to come together to make the 3. I'm going to stick with my colors here. I also know that position 2 times position 4 has to make the positive 14. And then, so what makes the negative 13? That's the trickiness. That's the loops. This times this has to add to that times that to make the negative 13. Now, it seems a little overwhelming, and it is. It's kind of a process, but once you do a couple of these, you'll get it. You'll get it. Trust me, if you are really trying, you'll get there. All right, so let's go back now and let's start talking about this x. So this x comes from the original expression. So we find the top number that what goes onto the top of the x by multiplying the first and last terms together. So 3 times 14, that is positive 42. Then the middle number goes on the bottom, negative 13. So if you want to draw some arrows on where those came from, maybe I'll do a different color again. I don't know if this has helped. Maybe too many colors is bad, but the first thing I do is I mult those together, and that's what goes on the top. Now, these numbers on the side here, the two numbers that I'm trying to figure out here, these two numbers need to multiply together to make this number. And then these two numbers also have to add together to make this number. Now, like I said, this feels kind of overwhelming. I get it. But it won't be the more you practice it. All right, so let's start off. What two numbers multiply to make 42 and then also add to make negative 13? Well, it's much easier to figure out the numbers that multiply to make 42. That's a fairly small list. Adding numbers, there's infinitely many. Technically, there's infinitely many here, but we're ignoring all fractions and we're ignoring all roots, all irrational numbers. We're only talking about integers here. So that's the list you want to look at. Now, like I said before, on the front side, some of you guys can look at 42 and boom, know how to break it down. If you can't, if you were like I was as a kid when I first learned how to do this, I couldn't do that in my head. My buddy Fox could. Oh, it drove me crazy. He was always faster at breaking these down than I was. So I'm going to take this 42. I'm going to write up here in the corner. I'm going to start to break down 42. If you can't do that in your head, grab your calculator. I know that there's some sheets that you've used in the past, but you're in pre-calc now. You got to know how to do this right off the bat. Now, the first one is always the easiest one, 1 and 42. Don't overthink it. That kind of gets you warmed up. Then I recommend, instead of just jumping around trying to find numbers that go into 42, go in a consecutive order. So I'm going to try 42 divided by 2. Obviously, it was even, so we knew it would work. 2 and 21. Now, here's a trick. If you want to try to remember more number tricks, if 3 goes into this number, then you can break it down again. If 3 doesn't, then you can't. Then the same kind of argument here. If 4 goes into this, then you could break it down with 4. If 5 goes into this, you could break it down with 5 and so on. So that's kind of a way, once you factor something, you can see if what you have left over is still divisible by other numbers. Now, if you don't want to remember that stuff, then just keep typing 42 divided by and go to the next one in the list. Divided by 3 is 14. 42 divided by 4, I know this won't work because when I divided by 2, I got an odd number. So 2 won't work again, but that's okay. So 4 doesn't work. I know 5 won't work because 40 doesn't end in a 5 or a 0. Then I try 6. Now here's a hint that you're done looking, because the next number that I would try would be 7, and that's already on my list. So you never have to check. If you go in order, if you jump around, this doesn't work. But if you go in order, once you check all the numbers to the next number on the other side, you don't have to keep checking. All right, so now I want to find a number that multiplies to make 42 and adds to make negative 13. So do those add or subtract? Now you just need to get it to combine using adding or subtracting. That makes 41 or 43. This makes 19 or 23. Subtract them, this makes 11. Add them, this makes 17. Subtract them, that makes 1. Add them, that makes 13. Boom, that's the one I want. So now I'm going to highlight this. And then I'm going to make sure that I need to build a negative 13 and a positive 42. So what kind of 6 and what kind of 7 need to add together to make a negative 13? If you're not sure, look, there's only 4 possibilities. 4 plus or 6 plus 7, that made 13, not negative 13. 6 plus negative 7, nope. Negative 6 plus 7, nope. Negative 6 plus negative 7, yep. So they both need to be negative. So now I'm going to come back to my little chart here, and I'm going to use this color, negative 6, negative 7. I use that color on purpose because those are the same things that I'm going to put on my loops. So this loop, when I multiply these two things together, they've got to make a negative 7. When I multiply these two things together, they got to make a negative 6. All right, so let's put it to work now. Let's do it. So green times green has to make a 3. So what are the only ways to multiply to make 3? Well, that one's pretty easy. It's got to be a 3 or a 1. So this has got to be a 3 or a 1 or a 1 or a 3. I can put them in either spots. So how do you decide? Well, that's where the loops come into play. So if I call this, let's say I put the 3 here. I'm not going to write it. I'm just going to think about it. If I put the 3 here, that 3 has to combine with this spot to make a negative 7. Is there a number 3 that you can multiply by 3 that makes negative 7? No. Is there a number that when you multiply by 3 makes a negative 6? Yes. So I know that's the 3. Now, like I said, if this is a 3, this has to be a 1. And then just finish your loops. And if you did it right, if you pick the right numbers here and the right numbers here, this part will just fall into place. 3 times what kind of number makes a negative 6 would be a negative 2. And 1 times a negative 7. Notice, these two numbers are never negative. If you need negatives, you're going to put those in the middle. So, what did we get as our answer? X subtract 2, 3x subtract 7. Now, what I used to do when I struggled with this was I would then instantly distribute. I would distribute to see if I got back what I had originally. X times 3x, and it actually helped me become a really quick distributor. X times 3x is 3x squared. That makes a negative 7x. That makes a negative 6x. Minus 7 minus 6 makes negative 13. Negative 2 times negative 7 makes a positive 14. We did it. We did it. We did it. What do you think? All right, let's do another one together. Unless you feel real ready, feel free to go ahead and pause, but I'm going to talk through one the long way. Okay, so I'm looking. I notice that I can't factor anything out. 10, 17, 6, nothing in common. There's not dopes because there's not two pieces. It's not factored by parts because it's not 4. So this must be X factoring, or probably is going to be X factoring. So X factoring has these characteristics. And I know there's going to be an X in front of that term and X in front of that term. Then I also have to multiply 10 times negative 6 is negative 60. And then the middle term goes on the bottom, negative 17. Now I like to highlight stuff. I like to correspond that position 1 and position 3 make the first term. Position 2 and position 4 make the last term. And then the combination of these loops makes the middle term. Okay, so now we want to fill in. I've got to find two numbers that, I'll fill in this chart again just as a reminder. We need to mult and add. Now look, this is not so easy. To me, this is not one that I could find out quickly in my head. So I would definitely make a chart. So I'm going to go over to the side here. I'm going to make a little chart down this in this position. So let's start with negative 60. I need to build a negative 60. Now, I'm not going to worry about negatives and positives until I figure out which two can even combine to make a 17. Then I can worry about what their sign is. So 1 and 60, 2 and 30. Notice I'm going in order. 3 goes into, one way you can play this game, does 3 go into this? Yep. And so that would leave you with a 10, and 10 makes it 20. I know you could have done that in your head. When I check for 4, I go back to 2 and I see if this is even. It is even. That means 4 has to work. So I cut that in half. Basically, I'm taking the 2 out of this and I'm putting it with that 2. So that's going to leave me with the 15. Then I look, does 5 go into any of the? Yeah, 5 goes into that. So I'm going to take the 5 out of that. I'm going to put the 3 and the 4 together to make the 12. Does 6 work? I go to the 3 and see if it's still even, and it is. So that's 6. I'm going to take the 2 out of that. That's going to be 10. Does 7 work? 7's always kind of a weird one. No, it doesn't work. 8, go to 4 and see if it's still even. Nope, 8 won't work. 9, go to 3 and see if it's still divisible by 3. No. 10, yes, 10's the next number, but we already have it listed. Because I went in order and I checked all the way till I got to the other side, I don't have to keep checking. I don't have to check 11 or 13 or 14 or 16 or 17 because I went in order, and so I didn't skip anything here. That means I won't have to check these over here. Now I need to find something that makes a 17. 1 and 60 or 59 or 60. This makes a 28 or a 32. This makes a 17 or a 23. There we go, right? 17 and 23. Let's just keep checking for a minute. So 17 if I subtract them. That makes an 11 or a 19. That makes a 7 or a 17. Now you got to be careful once in a while. I picked this on purpose because I wanted to point out just because you found one doesn't mean that there isn't another one that can work. Now we would have realized that it wouldn't have worked pretty quickly. Like let's say that we picked this one. What kind of 5, what kind of 12 would we need to make a negative 17? Well, I'd need negative 5 and I would need a negative 12. So when I put those in my chart over here, what's negative 5 times negative 12? That does not make negative 60. I can't have them both be negative. So I can eliminate that one. But it's worthwhile to check. Take the time to actually check. What kind of 3, what kind of 20 do I need to make a negative 17? I need a positive 3 and a negative 20. Those do multiply to make negative 60, so we're good to go. So now I'm going to go positive 3, negative 20. It doesn't matter where you put these. It doesn't matter where you put them over here. That will all come out in the wash. If you do it the opposite of what I did, you'll just get that this term will be first and this term will be second. Those will just be flipped around, which is fine because multiplication is commutative. All right, so now I'm going to place the 10 first. Now here's where things get a little bit more complicated than the last example because the last example, this number was prime. So I can break down 10 into 1 and 10 or 2 and 5. I'm going to try 2 and 5 first. So let's start 2 and 5. And now that's just because I guessed. I just picked it. Okay, 2, could that make 20? Sure. Could 2 make a 3? No. So I know this has to be the 2. So if that's a 2, then that has to be a 5, right? 2 times 5 makes, but that can't make a 3. So 2 and 5 is out. So I know it's now 1 and 10. Okay, let's try the 10. Could the 10 go here? Yes, because 10 can make 20. Could the 10 go here to make 3? No. Could the 1 go anywhere? Yeah. So the 10's got to go here. The 1's got to go there. 10 times what makes negative 20? That's a negative 2. 1 times what makes positive 3? That's a positive 3. Donezo. Now I like to rewrite it so that I can do a quick distribution and see if I did it correctly. 10 times 1 is 10. That's a negative 20 plus 3. Negative 20 plus 3 is negative 17. 3 times negative 2 is negative 6. We got it. All right. Ooh, we got an equal sign. Oh, no. No, that's no big deal. That just means that we need to solve it at the end. So I'm going to write a little note here. Notice you must solve. So we just have to what's called ZPP, and I'll talk more about what that is when we get there. So I'm going to start off again. Anything in common? Can I factor out? Nope. Is it dopes? Nope. There's more than 2 terms. Is it factor by parts? Nope. There aren't 4 terms. So this has got to be regular X factoring. I'm gonna go with dark purple this time. So I'm going to put my X over here. I'm going to put my parentheses here. So that's every problem starts off the same way. I might as well put my multiply in there too. 6 times negative 20 is negative 120. Crap, that's not going to be fun to break down. And then positive 7 goes in the middle. The middle goes on the bottom. And I like to highlight every time until I become an expert at this. I like to highlight what makes what. This and this make the 6. Position 2, position 4 make the negative 20. And then a combination makes the positive 7. All right. I'd encourage you to pause here, see if you can break this down on your own. Let's see how you did. So I need to break down negative 120. Yikes. Negative 120. So 1 and 120. 2 goes into that, so 2 and 60. 3 goes into that, so 3 and 40. 4, 2, yep, that breaks down again by 2, so that's 4 and 30. 5 goes into that, so that's 5. That would leave a 6, 5 and 24. 3 is still divisible by 2, so that's 6 will work. 6 and 20. Oh, man, come on. Can I get to it before the circle? Will 7 work? 7 doesn't go into any of these. Well, 8, yes. 8 and 8 goes in there. 8 and 15. 8, 9, 3 still divisible by 3? No. 10, 5 still divisible by 2? Yes. 10 and 12, and then 11, so we're out. Okay, so I almost made it. Not quite. So now I want to find the ones that come together to make positive 7. So that makes, subtract those two, that's 119. Add them, that's 121. Nope. 60 take away 2 is 58. Add them, that's 62. Nope. 40 take away 3, that's 37. Nope. Add them, that's 43. That's 26. That's 34. That's 19. That's 29. That's 14. That's 26. That's 7. Yay! This is not 7, so there's my combination. Okay, what kind of 8, what kind of 15? I need one of them to be negative, and I need to get to a positive 7, so the 15 needs to be the bigger of the two. That means the 8 needs to be negative. So now I'm going to take those and put them over here, a negative 8 and a 15, a negative 8 and a 15. Now, like I said, you don't need to show all this work if you don't need it. If you can just look and figure it out, go for it, man. Go for it. But my system, especially initially, I think it's really effective. And kids, it really makes you see how this process works. I'm going to try to place the 6 because the 20, I could place the 20, but the 6 has less factors. So let's try 6 and 1. 6 doesn't make 15. 6 doesn't make 8. So 6 and 1 is out. So it's 2 and 3. 2 doesn't make 15, but 2 makes 8. That's nice. And then the 3 can make the 15. Finish the loop. 3 times 5. So I'm going to leave that as a positive. 2 times negative 4. But why aren't I boxing this in? Because what does this equal? This equals 0. So I need to include that 0 from here and keep it down here. Now I'm going to do something called ZPP. You're going to hear me talk about ZPP. You're going to hear me talk about it over and over and over again. This is called the zero product property. The zero product property says, think about it. I'll try to, is there a little spot maybe down here in the corner? A times B equals 0. Okay, let's say this number is the number 6. 6 times what equals 0? Well, if this is 6, what does that have to be to get to 0? It has to be 0. Let's say this is the 6. Then what does this have to be to get to the 0? It has to be 0. So if you have things multiplied together that equal 0, at least one of them must be 0. So I come up here And using that idea, this times this equals 0, then the first part must be 0, or the second part must be 0. Now I've taken something that's fairly complicated, a complicated quadratic equation, and I've made it into two linear equations, which are really easy to solve. Add the 4, divide by 3, I get x equals 4/3. Subtract the 5, divide by 2, I get negative 5/2. These are my solutions. These are my factors. So you got to be able to recognize when you're going to factor and when you got to go that extra step in ZPP. I will take off points if you ZPP when you shouldn't, or if you don't solve when you should.